Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers air handling units, discharge air temperature.
This section will focus on why we do the discharge air temperature reset and how to do that. So feel free to interrupt me if you cannot understand my English or you want to you have any questions or concerns. So we want to know the discharge air temperature set point is too high or too low, or is there any opportunity to reset the set point. Sometimes we call this supply air temperature reset. So for each air handler, we want to monitor the discharge air temperature set point and the actual measured discharge air temperature. So we want to look at the deviation between the discharge air temperature and the set point, see is that far off from the set point or not. Also, we want to look at, see if there any temperature is too high or too low. Is there any opportunity to save the energy? So why we do the discharge air temperature reset? Why we just supply 53 or 55 degree supply temperature all the time? So anybody can give me some answer?
Overcool the building.
Overcool the building, yes.
Have to use reheats.
Yes, reheat is big time.
Yeah, if your building is in heating and you're
Yeah.
supplying 55 degree air and you're reheating everywhere, that's wasting energy.
Yes, that's if you eliminate that kind of reheat, you can also save the cooling energy at the same time. And also the thermal comfort. Some places may have the draft or the cold complaints because if the discharge temperature is too low. So how many buildings do you do the discharge temperature reset in your buildings? All of them? Okay. One of the questions is why we have this kind of existing discharge temperature set point. So it could be come from the initial engineering design. So they put a temperature set point there and continues use that set point. And also it could be override, and the people forgot to release that override of the set point. What kind of reset schedule do you use? Do you have based on the outdoor temperature or based on the cooling zone, heating zone?
Return temperature.
Return temperature? Mm-hmm. Anything else? Outside temperature. Yeah, I think it's, most building we have seen is just based on the outdoor temperature, use the linear reset.
Now, I use outside air temperature to initiate the original temperature set point, which would be 55 during the
Yeah.
summer,
Yeah.
or somewhere around 65 during the winter.
Yeah.
But then I modify that with an offset based upon my return air temperature. So that as the return air temperature goes up or down, I can raise or lower my supply air temperature to compensate a small amount.
Yeah, I think that's a good approach because that's a combination of the building load condition and the ambient condition. So I think that's a very good combination. Compared with the conventional, just a linear reset, because linear reset is good for some ambient-driven buildings. So if you have like less building, light building mass, it could be work. But for internal heat gain-driven buildings, if you have a lot of computers, a lot of lighting, a lot of equipment load, which might be not the best options. Look at retain temperature is good. And also if you have VV box, so you know how many zones in cooling mode or heating mode. You can look at those zone conditions, collect all those information as factors to reset the discharge air temperature set point. So for example, you can look at if you want to have very conservative way to do the reset, you can look at the warmest 3 zone or couple zones. And also you can look at how many zones in the heating mode. You count for example, if you have 80% of zone are in the reheat. So that means you have the opportunity to raise the discharge temperature set point. And also, some zones, like say, outdoor temperature reset can be a good, as you just said, as the initial points to do the reset, have the range. Like like for example, in the summertime, outdoor is like 80 degree or 90 degree. You don't want the discharge temperature go to 70 degree. You know that. So you can use that to have the high-low limit for your reset range. So that's a good approach. Some people may have questions. How do we coordinate the static pressure reset and the discharge temperature reset? Because some place you may have VFD installed in the fan, so you do the static pressure reset. And you also have the discharge temperature reset. So for our experience, we have been to one of bank building. They have a lot of big trading rooms, a lot of internal heat gain. So they have the VFD in the supply fan. So they do the reset of the discharge temperature and also the static pressure reset. So the situation we run into is the fan is running at 100%, almost like 60 hertz. And also they supply discharge temperature at 62 degree. So do you see any problem of that kind of setting?
Lower your supply temperature and that'll lower your speed.
Yes, I think that's a really good answer for that, because we know that if that's you know that building load is low. When the fan is running at full speed, that means they try to put the full cooling for the building. If at that time your supply temperature is higher than 55 degree, you lose the opportunity to reduce the fan speed. And so that's why we want to see how the building load looks like. And the fan speed is a good indicator of the building load. So if we know the fan is running 100%, that means they have the big requirement of the cooling. So at that time, we could lower down from 62 degree to 55 degree. You still remove the same amount of cooling, the heating from the space, but you save the fan power. So that's one thing we can consider. So here is a couple examples of the discharge temperature reset. This chart shows a discharge temperature set point and the actual discharge temperature. So you can see the temperature varies from 60 degree to 65 degree. And we can see this is a good example of a reset schedule. And this one, you have 3 days data, and you can see the discharge temperature set point is 52 degree constantly. There's no reset schedule. And that means that's opportunity. If we look at the zone condition or the ambient condition, we might have the opportunity to do the reset. So do you have any question for the discharge temperature reset?
Just want to make sure I understand that. If I have 2 variables in play to satisfy my set point, one of is I can slow down the fan.
Yeah.
The other one is I can lower the discharge temperature. Which one is the better strategy, or is the strategy to do both?
That's great questions. So in a lot of times, the operator, they may run in this kind of situation. So my recommendation would be, because we consider the cooling load is constant. We remove the same amount of cooling or heating from the building. So we may supply the cold temperature, for example, like 55 degree or 54 degree, and run the fan, reset the static pressure based on the building load. When the fan speed reduced to a certain point, let's say 50% or minimum, running at a minimum fan speed, we know at that time we may have the opportunity to reset the discharge temperature at a higher set point. because we already saved the fan power. When we save the fan power and building from the reduce from the cooling, maximum cooling to partial cooling load, at that condition you have the opportunity to do the reset. If the fan is running high speed, for example 90% or 100%, you might have limited opportunity to do the reset, right? So I think my recommendation would be do the static pressure reset first. When the fan speed reduced to certain limit, you can do the discharge temperature reset. But the better answer is to also collect the zone conditions. So we know how many zones are in the heating mode, how many zones in cooling mode. So collect all those information to help you to reset the discharge temperature at a high set point. Did I answer your questions? Yeah.
I'll just say one thing related to that. The other concept, like Gupong says, if you can count how many terminal boxes are in heating and cooling, that takes more effort at a controls level to write code, and to even go further would be to grab the VAV box, terminal box position of the VAV damper. Now on the ALC stuff, it's very hard to get that data for whatever reason, unless we're missing something. We'll talk to your guys later today. But some vendors give you that data. It's a calculated value. If I know my approximate VAV box, terminal box damper position, and if I average those terminal boxes, we know from experience you're always going to have one or two terminal boxes that are always going to be 100% open. Either they got a bad sensor, they got a ductwork issue, they got whatever myriad of problems. Those need to be fixed. But if I base it on some control sequence, say once I have one VAV box that's at 95% damper command, then I'm driving to a higher static pressure or a lower temperature, you might be false loading your system at that point in time. And we typically see that. So when I base on an average, we generally say if the average of all your VAV boxes damper position is between 40 to 60%, if I'm at 40%, keep your static pressure, reset it to some low value. You know, it might be 1 inch, it might be 3/4 of an inch. Well, by doing that, I'm slowing the fan down. Now I'm going to force my boxes to actually, well, you're not giving me enough static pressure, I'm going to start opening up. And they're going to sit there over time and do this kind of breathing exercise where they're opening up more at the box or restricting more as my static pressure increases incrementally. We don't recommend a drastic change over time. It might be every 15 minutes, 5/100ths of an inch reset. The bottom line is, if my boxes go more open, I'm going to get better airflow into my space versus a damper that's restricted. Okay, we all know that. If you got dampers that are opening up, you're going to get better airflow in the space, better churn in the space. You're going to move air. You're going to get better air delivery into the space versus a damper that's restricted way down. And dampers typically get restricted down because my delivery temperature is way too cold. If I'm delivering 50, 55 degree air and it's moderate, and I don't have a load, I don't need as much air. So now I'm going to be challenging my spaces. So again, it's a new concept, but we're actively pursuing that and seeing that we can still maintain space temperatures, airflows generally. And then if we got onesie, twosie spaces that are problems, those are the ones we want our technicians to go look at. Do I got a bad damper, bad sensor? What's going on in those spaces?
On your static pressure, one of the problems you have is the VAV boxes are designed for 1 inch of static pressure. If you get below 1 inch of static pressure, your VAV box does not function properly. It doesn't know how to read the airflow through the K factor that we use in these VAV boxes. So normally what we work with is if you're at 1 1/4 inches because you're 2/3 down the duct with your static pressure sensor, that you want to be at least 1 1/4 inches at all times, or you can go higher. But if you get below 1 1/4 inches, you begin to have your end boxes not function. They begin to float, so you won't get good control.
Yeah.
It depends on the box size.
VAV boxes are all designed, regardless of the box size, based upon 1 inch of static pressure. That's a national from ASHRAE code on how you design your boxes from everyone that you receive. So when you get below 1 inch, what ends up happening, the diameter, the circle that they use, which is usually 6 inch or 8 inch, where they have their flow meters and everything else, won't get sufficient flow through it, and therefore they can't operate properly. So the dampers will start modulating all over the place.
Yeah, I'm not going to argue on that 1 inch or 3/4, but and it's a good point. I think the other thing we all need to remember is we're dealing with instruments. Again, static pressure sensors, one sensor. Return air sensors, one sensor. If we're going to base our control, which we typically do, on that one sensor, are we checking it for accuracy and calibration? Probably not. Should we? Probably yes, because it has big impacts on how we're resetting, even outside air temperatures. If I'm doing a reset off outside air, I better be checking its location, its accuracy, and its calibration.
Well, static pressure is critical for your system.
Yeah.
And then usually you use a Maymac, or you'll use a more sophisticated item
Yeah.
that usually holds calibration for a long period of time, and then it'll sail off to a really bad count.
Yeah.
But I agree with you, it's a problem.
Yeah.
But I've done work from Massachusetts all the way down to Florida as far as for large universities and building systems. And Titus and all the rest of them is designed based upon 1 inch of static pressure. And you can look that up in the ASHRAE if you have to.
Yeah. No, I go right to the vendor, and they're, again, depending on who their box, their design, if they've got reheat coils and added pressure drops, they'll tell you right in their charts. If you got a reheat coil, then you may need 1 1/4. And again, that's at the far end. If I got that high of static pressure, as I get work back towards the fan, I'm going to have, as I work back towards the fan, I'll have even higher static pressure. So, yeah, but I think these are all good discussion points.
Yeah, these are all good comments. For the discharge temperature reset, I think which approach you want to take is really depends on the your building personality. Different building have a different setup. You cannot say, okay, you can only do the OA reset, or you can do the box feedback, because some building you even don't have the damper position or the VAV box information. So it's really based on the build, what kind of BS you have, and also the building personality to set up the low, high, low limit, and also the humid area. And for the dry climate, they have different high or low limit you can go to. So anybody has other questions?
Yeah.
Okay.
Well, in a cooling mode for a system normally set up to discharge 55-degree
Yeah.
air on a high load day, what would you say your limit would be on raising your discharge air temp?
That could depend on the climate zone. Like say if it's a humid area, probably we have to be very careful. We don't want to go like say 70 degree or 68 degree, because we don't want to bring too much moisture to the building. So, but for some dry climate, you can set up as high as like a 72, or use the retail temperature as the
Okay, well, say a very humid climate, what would be your limit?
I think in the winter time, I think it should be safe to go to like say 65 degrees should be fine. I think.
Summertime?
I mean, like the shoulder season. Yeah.
So one other option is what you got: outside air humidity, you got enthalpy.
Yeah, enthalpy.
You could use that as a reset for your high limit. So as you see your humidity and enthalpy levels starting to go up, you start resetting your high limit back down. Again, what we're seeing is weather conditions change even here on the East Coast. You guys have had a relatively mild spring. That's what I'm hearing. We came in yesterday. It was 80, 85. Actually, I thought we were on the West Coast because it was nice and comfortable. Today, not so comfortable. So things change. They're dynamic, nothing static. But what we typically see in our control algorithms is we set them up as if things were static. It's always humid. Therefore, we're always going to be at this value. So again, is there a value? Yeah, there might be if it was always this condition. Should I consider something that's more dynamic that would reset based on dynamic conditions? Sure. What are those? That's where retuning says, let's play with it and see, but if I'm going to base it on outdoor air conditions, whether it's enthalpy, temperature, golly, I better make sure I got accurate sensors.